Good afternoon, everybody. Thank you for coming to our session. So today we'll be talking about the integration of Kata containers with Openstack Zun. So this is mostly about how we integrated the latest hottest topic, Kata containers, with the container service, that is Zun. So before we go into the details of the presentation, we would like to introduce us. I am Madhuri Kumari, working at Intel as a software engineer. I am a co-reviewer in 2 of the OpenStack projects, Magnum and Zun, and I have recently authored a book called Containers in OpenStack. And here is my co-speaker, Surya Narelda. He's a senior principal engineer from Dell. He's been working on OpenStack as well. So this is the agenda for our presentation. So we'll briefly start with what OpenStack Zun is, because many people have this question, what actually Zun is and how different it is from Magnum. So I'll try to explain what Zun is and how is it different from Magnum, and the basic workflow of Zun, how does it integrate with other components and Docker as well. So, and then I'll talk about the runtimes that are available in Zun. The next would be the introduction of Kata containers, and then how Kata containers and Zun are working together. And then we'll be talking a little bit more into detail about the Kata containers and how does Docker create works with Kata container. We'll be seeing that as well. So, and finally, we'll be talking about what are the next steps that we will be doing in Zun to support Kata containers. And finally, we'll be showing a demo with Zun, showing how you can run Kata containers with OpenStack Zun. So let's begin. So OpenStack Zun, what OpenStack Zun is. So in a very simple term, it's the container service in OpenStack, so which provides you a unified API to run your containers on top of OpenStack. So here you can see this is the this is like a diagram which shows how Zun is placed in the OpenStack ecosystem. So basically, I would say we have a compute service, or a compute service that is backed by any COE or a container runtime tool. You have Docker installed on the compute host, and this COE can be actually installed by Magnum. So Magnum actually does the installation of COE on top of OpenStack ecosystem. And all the other components like the Keystone for the authentication, Glance for the images, and Cinder for the volume, and Neutron for the networking purpose. And this is the backend which we use for Zun. And we finally have a Zun service which will provide you the API to run containers on OpenStack ecosystem. So this is how OpenStack Zun is placed on different components around, and you have been using other components of OpenStack to provide you a unified API for running containers on top of OpenStack. So, and today it supports multiple runtime. We have a support for running the regular runc containers, and we also have support for running clear containers with Zun. You just have to provide the runtime which you would like to run your containers with, and you don't have to manage your host for running containers. You just have to have your compute node where you have the required runtime tool to be installed, and you can use it with the Zun. So Zun hides all the complexity of how it talks to Docker, and the network is created, the volume is created for your container, and provides a very simple API to manage your containers. And today Zun supports the Docker driver for running your containers, and it leverages the other projects for Glance for providing the container images. It downloads the images from Docker Hub if it doesn't, and also have an option of saving images to the Glance. You can also use the image from Glance as well. So Zun has image driver, for example the Glance driver and the Docker driver, which downloads the image from the Docker Hub. And for the networking purpose, we have we use Courier. So Courier provides the networking resource for the containers in Zun. And Zun does not do any kind of orchestration. We use Heat to do the orchestration. So we have Zun resources in Heat, which you can use to create a complex application which can consist of multiple containers. So this is a very simple diagram of what's the architecture of Zun and what are the components there in Zun. So we mostly have just two components. One is the Zun API and the other one is the Zun compute. So you can have multiple instances of compute services running and a Zun API service to talk to this Zun compute. So Zun compute is the important service which does all the processing. It talks to multiple services to provide you your containers. So if you can see in the diagram, Zun talks to Glance for the images, Neutron and Courier for the networking purpose, and then it finally submits the request to Docker for creating your containers. So if I take an example, how if you say like I want to create a runc container or any clear container with Zun, so the request will go to the Zun API service, and then the Zun API selects a node which satisfies the resources for your container and forwards the request to Zun compute service. So Zun compute will then talk to all these services for the necessary resources for images, for network, and finally submit the request to Docker for creating your container. So there are two kind of calls we support in Zun. One is synchronous and another one is asynchronous. There are requests which may take time, like for example the create takes time. It needs to download the image and create the network. So these calls are made asynchronous. So the request is submitted to Docker and we return a response saying your request has been accepted, and we update the database accordingly after we receive response from the Docker. And this is the like what advantage do we provide if you use Zun? What's the actual advantage of having Zun in OpenStack ecosystem? So earlier, if we earlier we only had Nova for running your workloads on VMs. So for an example, if we take this application, this is an application where we are running a very lightweight web server and a database. So we used to run all these kind of application services on different VMs, where this is not a proper use of the resources. So with Zun, you can run any lightweight service on this container and the heavy weight resource, any application or service on the VM, and the Zun will do the networking for you. So the communication between a Nova VM and Zun container is possible. So this way you can implement any kind of application and try to run different setups for your application so that you utilize the resources in a proper way. So the next slide is like how Zun talks to different components and Docker to provision your container. So today there are multiple ways to talk to the Zun API. You can use the Zun CLI or the OpenStack CLI to send your request to Zun. Then Zun API sends the request to the compute host. That we can have multiple compute hosts, so that selection of host is done by the Zun API, or you can say the Zun scheduler, but we don't have any individual service or binary Zun called as scheduler. So it is done, it's a very simple way. It does the filtering and returns you a host to run your container, and the request is forwarded to the Zun compute service, the selected Zun compute service. And then compute service talks to Neutron to get the available networks. If it gets the network, it sends the request to Docker to create the network for you. So the Docker we have this plugin Courier for the networking purpose. Docker sends the request to Courier to create the network, and then Courier talks to Neutron for creating the network and port that is needed for the container. And after the network is created, the request is sent to Docker with the created network to create our container. So and Docker creates the container and finally attaches the Docker to the network. So this is the basic workflow of how the request travels from the client to the Docker and how it interacts with Neutron and any other service for the necessary resources. So by default, we support runc container in Zun. So this is the workflow, like the request goes from Zun API to Zun compute, and then Docker, and then runc runtime. Similarly, we have one more runtime supported. The clear container, we have not mentioned it here because we'll be removing it to support Kata containers. So in this case, Docker will have multiple runtimes configured. One is the default runc, and the another one the Kata containers. So the operator has to install Kata container on the compute host and configure it as one of the runtimes for Docker. And it's very simple to select any kind of runtime in Zun. So you just have to specify the runtime parameters, the runtime option, like which container you would want to run with Zun. So this will go and talk to the specified runtime and create the container for you. So now Surya will take over from here.
Yeah, thank you, Margaret. Can you hear?
Yes.
Hello? Yeah, thank you. So I think we've established that now Zun perfectly works well with containers, right? And we have seen the runc, the way of doing with runc. And then in the previous summit, we were able to show how Zun works perfectly fine with clear containers. So going towards clear containers and then Kata containers is a natural transition for Zun, because they are secure containers. Every kind of workload which customers might think is important can be run in these kind of containers. They have the potential of replacing the regular VMs, because you don't need to run in a VM when you have a container which is equally secure and can give the benefits of controlling it from OpenStack. So the diagram right now we see here is the overall architecture of Zun API and how it talks to the Zun compute. The Zun compute, just let me have a pointer. So this is Zun compute components, and then we talk to Docker. And the Docker can talk to various command lines, the Kata container runtime, and then either the runc or Intel clear container CC runtime. So let's look into a much more detailed Kata containers architecture that would give us an idea of how things are designed here. So there are multiple sessions that happened earlier showing the similar architecture diagram, but we'll just look at the architecture diagram from the point of how we've done integration, how the API flows in, which component calls which, and then we will progress to the demo. Then when you see the demo, you would really have a very good understanding of how things are working. So as you can see, the top layer is the Docker or Kubernetes or OpenStack. The OpenStack here is the Zun component. And then we have various Kata specific components like the shim, the runtime, and the other component which is hiding here is the agent, which is actually sitting inside a virtual machine. Virtual machine is the container layer here. And the other one is the proxy component. So let's just understand the flow. Imagine a situation where I'm sending a command called Zun create. Zun create is, the expectation of Zun create is go create a container for me. And let's say if I'm talking to Kata containers, how does the workflow happens? So here is the call, Zun create has hit Zun API. Now Zun API goes and talks to the underlying OCI framework, which is the Docker in this case. And we have configured our Docker to go and talk to Kata runtime. So that's what we do. And here is our Linux compute host. We have the Zun API call coming in, and then we see the flow. So the Zun's call comes in first, and then you have the Docker. It's talking to the Docker right now. And then we have configured our Docker to talk to Kata runtime. So Kata runtime now takes the call, and it is the one who's really completing the task of providing a container and giving back all the answers that Zun is asking. So Zun basically gives a JSON file to Kata runtime. Now Kata runtime takes it, and then it does the further. So one of the first things that it does is create a namespace inside the Linux compute host. So this is the namespace in which every component gets created specific to Kata. So that's one of the first things. And then it creates a network ETH pair. So you have an interface vETH pair. It's called as vETH pair from between the namespace and the host. That's the first thing that it does. And then what it basically does is it creates a tap interface. The tap interface is the one which it gets created, which gets connected to the veth pair inside the namespace. This is all happening on the host. Remember, the compute host. Okay, and then once the veth pair is created and the tap is created, it spins up the VM. The VM is not a regular VM. This is a QEMU Lite VM. So basically, it's the QEMU that we use for VMs, but it's a stripped down version of QEMU Lite, where it does not go through the elaborate process of boot up. It won't do the BIOS routines and the ACPI routines. It just quickly goes through and calls the VM Linux. VM Linux is the binary which boots up Linux kernel. So you quickly call QEMU Lite just goes and finds the VM Linux and then boots up the system. So you pretty much jump into the kernel, which is highly optimized to boot really fast. And from there, the moment the VM Linux boots up, the first thing that comes up on a VM Linux inside the VM is the init process, right? Once the init process is ready, the agents start coming up. So one of the agents that comes up inside the VM is the Kata agent. And at the same time, a Kata proxy agent is created outside. This is the one. So this is a sequence of things that happens at the same time. And once the Kata proxy process is created, you have the sandbox environment which gets created inside the VM. So this is all happening when just one create command was going through, right? And once the sandbox is created, it goes to the actual process of creating the container. So the container image gets created inside the VM. And this is all handled by the sandbox via the Kata agent. So the commands come in from Kata runtime to the proxy, goes to the Kata agent, and then gets the sandbox, then we start having the container. So basically, the container is a lib container based container. This lib container is the same lib container we use for runc. So basically, what we are doing here is, we normally run a container on the host where we have a runc environment and a lib container. We take the whole package and put it inside the box. That's what is happening here. So because of that, it's kind of sitting in a secure environment, hardware secured virtualized environment, and you get the benefit of all the security features that the hardware is providing. Then once the lib container and the container have spun up, you have a process called Kata shim, which comes up inside the namespace. This is the namespace of the host. This is not the namespace of the VM. So this Kata shim comes and it connects with the Kata proxy using a gRPC socket, gRPC protocol, basically it is. So, and once that shim is created, sorry, I have to go back, I think. Yeah, once the shim is created, that's when the actual containers creation has completed. Basically, the shim is used to do all the standard in, standard out, and standard error kind of transparently send the data in and out of the container. If the container is running directly on the host, you wouldn't need these. But the container is running inside a virtualized environment, right? So we need to have some sort of proxies and shims to get the output of the container that's running inside and show it to the Kata runtime. So for example, if you run a container which is like container run some top-b or something. Top-b is a batch command. So basically it keeps running. Or top-n-b is something like which constantly shows the display on the terminal. You need to get the display out. How do you get it? You need to have a way of getting that outside the VM and passing it all over back to the Kata runtime and then to the Docker. That's when the user can really start interacting. So these are the components which help do that. So this is the kind of process that happens for a create. So whatever I have explained just now, it's in the form of a flowchart right here. This is from the Kata Architecture site. They've done a great job explaining each and every process. They have details about a create, a delete, a kill. Everything has a flowchart. You can just have a look at the link at the bottom. That's where you can go and have a look at it. I just explained one of the processes so that we have an idea of how the namespace and everything are created. Yeah. So now we'll just understand the demo that we have set up. So basically, we have used a dev stack with Zun and a Zun UI so that we can do things on the Horizon dashboard. And it's obviously using Courier for networking, Courier's Docker plugin. And then we are using Docker CE and Clear containers. So this is the DevStack configuration that we've used. So one of the things that we've done in the past is we've automated DevStack to go and install clear containers automatically. So that would install clear containers 2.0, which we don't want right now. We wanted clear containers 3.0. So the configuration clearly marks enable clear container is equal to true, which is a future option, right, not available right now at this moment. But what we have done is commented out the enable clear container is equal to true option. Is that right?
Yes.
Yeah. So, and also this option enables the Zun UI. So you have an option of creating containers on the horizon when you enable this option. So let's have a quick look at the demo. So we'll just launch a demo, and we'll have a runc environment spun up, and then we have a Kata environment spun up. Then we'll see how these two communicate with each other in real time. Oh, sorry.
It's not showing up on the screen.
How do I show up on the screen? Just a moment. Is this visible?
Yes.
Okay. So yeah, just so we set up. Basically, we are looking at the Zun list. Zun list shows us what containers we have.
You have to go back. This is the second video.
Okay. System on.
Yes.
Okay. So we're just looking at the current Docker information on the node. So if you see the runtimes, so we have already configured Docker so that it can understand both runc as well as the Kata runtime. Basically, that local.conf, which we have run earlier, would bring it up to the point where we can see that. Then the Kata runtime check just to see that this system is capable of running Kata containers. You can see that highlighted line, which clearly shows that the runtime is possible on this system. So we are looking at any existing Docker process, Docker containers. There's none on the system right now. And then we do a Zun list. Zun list is the same as Docker PS output, but all the containers which are spun through Zun. So we don't have anything right now. This is the Horizon dashboard, logging in. So you see that container section coming up because we have enabled Zun UI for that. And we only have a single tenant network. Yeah, that's the only single tenant network we have. We'll use the single tenant network to spin up the containers. We're creating a container with a name. And we pretty much are not giving any other options, just the name, and basically asking what kind of container would that be. So we've created the container. It's just creating the container right now. This is a default runc container. So we have a node here where it supports both runc and Kata container runtime at the same time. So users can choose what runtime they need at the time when they're spinning up the containers. So we do a Zun list. We've sent a container request from within Zun. So right now you can see this is a runc container with BusyBox. That's what we've asked for. This is the tenant network. And the same can be seen on the Docker. Docker PS shows you what kind of container it has spun, and this is a standard runc container. Quickly go into the container and see what's the host name. This is the host name. We'll go into the console and check if it's come up properly. Yeah, that looks okay. The container has come fine, and the console has connected to it. That's a success. So now go back to the terminal, and we'll quickly check on the Kata runtime list just to see if anything is there. Kata runtime shows any containers which are spun up using Kata runtime. Right now we have none. We only did a runc. So go back to the UI, create a new container, and give a name. Standard same BGBox image. One of the things that we do is specify the runtime. So earlier we did not do that, and it has done a default runc. Right now we have changed the runtime to Kata runtime. It's spinning up. Let's have a quick look at the Kata runtime list and Zun list to see how it's faring. So as you can see, the second runtime is the Kata runtime, and it's creating. So it's in the process of creating. Let's quickly have a look at the Docker PS. As you can see, it's still coming up. Okay, it's running now. The Kata container is running now, and you can see the second container that has come up here in the Docker PS output. And the Kata runtime list should show. Earlier it was not showing. As you can see now, we have a Kata runtime based container running on the system. So we just look at the process list to see how it's running in the system process list. As you can see here, the virtualizer is the QEMU Lite virtualizer. That's what I mentioned earlier. And if I click on the Kata container, we should see the details about it. It shows the runtime and the host name, just to quickly get into the console to see if things are okay. And the console directly shows us the screen of the Kata container. This is the one which I was talking about. The shim, the Kata shim comes into play here. When we are doing host name here, it's just passing through the Kata shim and showing us what's happening in the container. Just quickly do a ping between these two, a runc container and a Kata container right now. See how things are faring. So as you could see, it's pretty straightforward to implement Kata containers right now, and it just need one single host and the configuration file that we've shown, just to quickly try it out. And the documentation on the Kata side should be extensively. It's been written extensively to make sure how we install all the Kata components. Once we install the OpenStack, and then the clear containers components, and then we install the Kata containers components, and then do the necessary configuration, then we have it running. It's just pinging the node between the two containers. We're just making sure this is going through courier, so you can see the whole path between a normal runc container and the Kata container, which is sitting inside the QEMU system. Okay. Yeah. So that's the short, quick demo. Sorry. Short, quick demo. I think. What would be the next steps?
Okay, so this work of integrating Kata containers is not yet upstream, but I would say it is as simple as just providing the runtime that you want to run your container with. It's just the option -- runtime and specify the name of runtime you want to run. So the next step would be, we would be adding a plugin to the day stack so that it will install the Kata containers automatically and configure it as one of the runtimes for Docker for the development purpose for the developers. So we have not done yet, but we'll be doing it after the summit. And more advanced thing that we would like to do in Zun is, like, we would try to do something where we can segregate hosts for different runtimes. There could be a use case where operators or users would not want to run the runc container and a Kata container on the same host. So in that situation, we would be separating host for running runc and the Kata containers. It could be any because of any security reasons. So these are the things which we will be doing in Zun for supporting Kata containers. So, and if you have any more use cases, you can add your use cases to this link, and we'll be looking for it, and we'll implement the same in Zun. So thank you so much. That's all we have from our side. Any question?
You can just see the resources that
yes. we've
used. The last resource is the Kata Containers Architecture resource, which has the flowcharts. If you just have a look at the flowcharts and various scenarios of creates and kill and stop and every other scenario where how the flow happens, just have a look at it. Yeah, thank you.
Thank you.
Have any questions? Okay. Okay, thank you.
Sorry,
okay,
question.
Yeah.
Can this coexist with Nova and KVM on the same box?
Yeah,
yes, it can.
That's a very good question. It can coexist, yes.
Are there any known issues, or should it just work out of box?
As far as I've seen, we've tried spinning up normal VMs, and these VMs, it's fine. We haven't seen any issues as such.
Thank you.
Yeah.
Any questions? Okay. Okay. Thank you so much.
Thank you so much.